Hello, week 5 for hydraulics and geotechnical engineering CE review. So for this week, we'll be discussing about moving vessels on the subject fluid mechanics. Okay, so probably this is the last subject for fluid mechanics. Then we'll be moving to the first subject on the hydraulics, which is the Bernoulli's equation or flow. Now for this week, we'll begin with this one, the rectilinear translation. So imagine a vessel that will be moving on a straight path. Yan yung rectilinear. Now, the same sa dynamics natin. So initially, if this vessel contains water, of course, the water will be in the horizontal position, the water surface. Now, if it will move with a constant acceleration a, of course, the water will be in that position no? Now, we can calculate the angle of inclination of the water surface here, and let's call that theta. Now, that can be solved using this formula. Tangent of theta is equals to a over the g, where a is equals to the acceleration and g is equals to gravitational acceleration, or the gravity. Okay? Now, if that vessel naman will be moving towards an inclined plane, let's say that the inclined plane is at angle alpha with the horizontal. Of course, this water is also angle alpha, no? I mean, this water level, horizontal yan initially. Now, that water level will also be angle alpha with this ating horizontal plane. Now, if it will move with a constant acceleration a along that straight path, then we can calculate the angle theta dyan. Magbabago yung orientation niya or yung inclination. Of course, if that will move because of the reverse effective force, magkakaroon yan ng change in inclination. Okay? And by the way, these formulas pala is derived through the principle of reverse effective force, okay, from our dynamics. Okay? Now, the formula for that theta when we have an inclined angle plane will be this one. The tangent of theta is equals to a sub h divided by the gravity plus or minus a sub v. Yung a sub h and a sub v natin dito is the vertical and the horizontal component of our acceleration with respect to this inclined plane. So, if we are to look at this one, the same lang parang sa mechanics, no? If this is our angle, our acceleration, then this is our vertical component of acceleration, this is our horizontal component of that acceleration, no? And of course, if this is alpha, this is also alpha. Then, we can have the components. So, a sub v is equals to the acceleration sine of alpha. And the acceleration horizontal is equals to a cosine of alpha. Okay, so remember the notations. Alpha here is the angle of inclination of the ground. Okay. So, we have notations here or important notes para hindi tayo magkamali sa ating sagot. So, use plus here in the plus or minus sign. Use plus for upward motion. That means going up, no? And downward, negative for downward motion if the vessel is moving down. Okay? Okay. Now, we have also the vertical motion. Now, if we are to imagine this one, if this body will be moving upward with an acceleration a, walang magbabago sa orientation ng ating water surface, no? But yung magbabago dito is the pressure, maximum pressure or the bottom pressure ng ating vessel. And it will be given by this formula. Okay, try to imagine this one. If this vessel doesn't move, then the pressure at the bottom is gamma height lang, no? The gamma of the liquid times its height or depth, no? This one. Now, because of that movement, may reverse effective force tayo. Kaya may additional factor dito. And again, these formulas are derived from the reverse effective force because we are all after here to the pressure induced or the increase in pressure because of the movement. Okay? Now, pwede rin if this body is moving downward, and that would give us the same formula lang, this one. Okay? Now, ito yung mga notation natin. Note that the formula is positive, that one, for upward motion pa rin, no? And negative for downward motion. And take note that the acceleration is positive if acceleration yung terminology. And that will be negative if deceleration. Okay? Okay. Now, rotating vessels. So, imagine this one. Okay, we have a vessel, a cylindrical vessel, rotated about its vertical axis at an angular rotation omega. That is angular rotation, no? Imagine if iikutin natin to, then the water inside will form a paraboloid, no? If you can imagine on your childhood, if you try to rotate yung palanggana natin, no? Or balde, magkakaroon niya ng paraboloid of water. No? Okay, so this height of the paraboloid, yan yung makukuha natin or importanteng makuha natin to calculate the pressure at any points dito when this is rotated about its vertical axis. Okay? And let's call that y. And that y will be the function of r, no? Or r is a function of y, vice versa. Now, look at this one in the plane view. Okay. At any point of the paraboloid, kung titingnan natin siya in the plane view, it is a parabola lang, no? Parabola. Now, at this point, at any distance x from the center, we have the value of y, and let's denote that as y sub p na lang, no? Okay, so also at this point, if we draw a tangent line here, we can have angle of theta, no? Again, it is with respect to our x at any points on that parabola. Now that theta can be calculated by this one, omega squared x divided by g, no? Now, if we will differentiate this one, take note that tangent of theta is the slope. We can rewrite this one as dy over dx omega squared times x over the gravity. Slope siya, yung tangent of theta, if you remember, no? Then we will cross multiply this dx here dito, then integrating that one, okay? Cross multiply yung dx, then integrating both sides, then yp, let's just generalize this one, y sub p is equals to omega squared, of course nag-integrate tayo, x squared over 2g. Yan yung general formula at any points in the parabola. And actually, ito yung constant ng ating, di ba yung equation ng parabola is y is equals to 4a x squared, no? If nasa center lang yung origin. So, this omega squared over 2g, yan yung 4a natin sa parabola na yan, sa equation. Okay? Now, after all, we are always looking to the maximum height of the parabola. That's why the maximum height y here, since that is with respect to distance x, so we should take account the radius here, omega squared r squared over 2g yan. Okay? Ito talaga yung gusto nating kunin always dyan in analyzing problems like this one. Well, if specific yung problem, ano yung angle theta at any points on the parabola, then we can use this one. Okay? But as what is my experience, talagang y yung kukunin natin, yung maximum height ng ating paraboloid. Okay? So these are the notations. Omega is the angular speed that should be in radians per second. Y sub p, height of the paraboloid at a distance x from the axis. At any distance x. Now y sub p, this should be y, no? Y is the total height of the paraboloid. And g, of course, the gravitational acceleration. Okay. So let's try an example. Let's have situation 1. An open rectangular tank mounted on a track 5 meters long, 2 meters wide, and 2.5 meters high is filled with water to a depth of 2 meters. Okay, so for example, ito yon, yung track natin, mounted on a track of 5 meters long, 2 meters wide. So the 2 meters wide here is the perpendicular dito sa screen, no? If you can imagine that on 3D, 2 meters perpendicular sa screen natin. Then 2.5 meters high is filled with water to a depth of 2 meters. So ito yung depth ng ating water. Now, so the problems are determine the maximum horizontal acceleration that can be imposed on the tank without spilling any water. Okay, so paano natin yan ma-relate sa spilling? Of course, ganito natin siya i-analyze. If this will move with a constant acceleration a, for example, pag ganyan, no? Of course, para wala siyang acceleration, dapat up to this point lang yung water natin. No? Dapat up to that point lang. Now, this, in order for us to calculate the acceleration, maximum acceleration, para walang spilling, so dapat, di ba sa formula we have tangent theta is equals to a over g. Of course, walang problema sa gravity. Ang kukunin natin is yung theta. Okay, so this is one of the important matter, no? The pivot point of the water, yung parang saan siya nag-rotate is at the center yan always, no? By knowing that one, of course, this one is 2.5 and we have this 1.5. Then we can calculate the angle theta. Okay? We can calculate that angle theta. Okay, for part 1, tangent of theta is equals to acceleration over the gravity. Then, by this figure, considering this right triangle, this theta is equals to arctangent of opposite 0.5 over the adjacent 2.5. Then we have the angle of theta, 11.31. Then after this, we have this formula, then we can calculate the acceleration na, no? Cross multiply our gravity here, then acceleration, maximum acceleration without spilling is equals to the gravity tangent of theta, that one, or 1.96 meters per second squared. That is the answer, no? Or actually, you can just do the ratio and proportion here. This one is to that one is equals to a over g. The same lang yan. Okay? Okay, so number 2, determine the accelerating force on the liquid mass in kilonewtons. Okay, so the problem is accelerating force na. How can we calculate that one? Okay. Okay, so for part 2, remember, we have a formula, di ba? We have the formula of, by drawing the free body diagram, ito yung hahanapin natin yung accelerating force. Diba? Papuntang left yung ating movement. Then, paano natin makukuha yung accelerating force na yan, yung F? Equate natin yan sa reverse effective force. Yan yung concept natin. No, that is an imaginary force, unbalanced force dyan. So that means that the unbalanced force should be equals to the accelerating force, or F is equals to reverse effective force. Now that reverse effective force has formula. That is just mass times acceleration. No? Force is equals to mass times acceleration. So in this case, yung sinasabi niya is the accelerating force on the liquid mass. Then yung mass na i-consider natin dito is the mass lang ng liquid. Okay? Kasi depende yan. If sinabi niya the accelerating force because of this mass of the truck and the mass of the liquid, then we will consider the mass of the truck. Okay. By this one, we know that the mass is rho times density. I mean, rho is the density times the volume. No? So, the density of the water is 1,000 kilograms per cubic meters multiplied by the volume of water here. So, initially, we have 5 times 2 times perpendicular distance na 2. So, ito yung volume ng water natin. Then, we have the mass as 20,000 kilograms. Then, we can calculate the accelerating force. Mass times the acceleration. So, wala naman siyang sinabi anong acceleration yung gagamitin natin. So, we assume talaga nga itong acceleration natin yung gagamitin natin dito. Okay, so we have force 39.2 kilonewtons. The accelerating force in this moment. Okay? Number 3, if the acceleration is increased to 6 meters per second squared, how much water is spilled in cubic meters? Okay, so as you can see, ito yung acceleration na wala pang spilling of water. Kumbaga, andito pa lang yung water natin. No, hindi pa siya aabot. Now, if lalakas pa yung acceleration natin or mas bibilisan pa yung takbo, that means magkakaroon na ng spillage dyan. Okay, so ito yung hahanapin natin. Okay, so imagine this one. Huwag na lang nating ipakita yung truck. Yung liquid na lang. So, if this will move in a higher speed, it will tend to spill that water. Okay, so dalawang case scenario ito. It can be ganito, mag-spill ng yung water dyan, or actually, pwede ring pa ganito. Okay, ano yung na-observe nyo? So in this case, yung water level natin is andito pa sa front face ng ating vessel, no? So in the second case is lalagpas na siya. Pwedeng andito na. Okay? So how can we say that that scenario is this one or pwedeng sa second case? So i-check natin yan by using the acceleration na binigay. No? Let's call this case 1 and case 2 na lang. Now, of course, we have this formula. And take note that the acceleration is 6 meters per second squared. So, i-calculate muna natin yung angle theta because of this acceleration. So, that is 31.45. Now, in order for us to be sure kung anong case yung gagamitin natin, is to check natin. I-check natin yung this one. Angle of inclination dito. So, ito yung magiging basis natin. Mache-check natin if lumagpas ba siya dito or hindi. Okay? So, let's call this one as alpha na lang, no? So, that one, by arctangent opposite 2.5 over 5, then we can solve the alpha. Then, by comparing the alpha and the theta, this one, compare natin, as you can see, yung alpha is lesser than ating theta. So, ano yung ibig sabihin nito? Lesser than. That means, hindi siya lumagpas. Diba? In this position, mas maliit yung lesser than. In this position, yung theta natin dito sa case 1, dapat mas maliit siya sa alpha. No? But, as you can see, yung alpha natin is lesser than the theta. So, this theta, as you can see, in this second case, dapat mas malaki siya. Mas malaking angle of inclination siya dito sa alpha. Diba? Mas steeper siya dito, yung inclination. That means we are in case 2. Gets siya lang, no? Makikita naman natin sa drawing because of this one. So, by knowing that we are in case 2, so we can solve this angle, the spilling of water by using solid geometry. Solving the volumes, of course. No? So, ito yon. The volume of spill is the original volume of water. Okay, imagine this one. The original volume of water minus the final volume of water. Of course, no? Nag nag um, nag-spill naman yung water. Kung ano yung original volume, then kung ano yung matitira, i-minus natin, ito yung na-spill. Okay? Or, we can also say that the spill water is equals to final volume of air minus the initial volume of air. Pwede rin ito. Okay? So, I suggest, if we are in case 2, gamitin natin to. Yung water yung ating basis. Because mas madali kunin yung volume nito sa triangle. No? Where if we are in case 1, mas madaling gamitin ito. Kasi yung air natin yung naka-triangle dito. Okay? Now, isolve muna natin yung x na to. Ito. Kasi we are in case 2, di ba? Ito. So, to solve that, take note that we have the angle of theta. So, that will be 2.5 over tangent of theta. Okay? So, we have 4.09. Now, the volume of spill, by using the this one, original volume of water minus the volume of water, final volume of water. So, that will be, this is the volume of water initially, no? 5 times 2 times perpendicular na 2 minus yung volume ng water natin, final volume. Ito, no? So, take note, this is a triangle. So, 1/2 of base, which is 4.09 times height na 2.5 times perpendicular distance na 2. So, we can have the value of volume of spill as 9.78 cubic meters. Okay? I hope you understand this one, ha? Pwede rin gamitin natin ito in terms of the air, but as you can see, trapezoid yung air natin dito. Mas matatagal lang tayo, no? Compared dito. Compare sa water. Well, if we are in case 1, mas magandang gamitin ito. Volume of spill, air yung basis natin. So, this one, the final volume of air here is triangle, then minus the initial volume of air, which is, we can solve that using this one. Ito, yung initial volume. Okay? Now, that is the answer. Okay, so another situation. A closed horizontal cylindrical tank 1.5 meters in diameter and 4 meters long. Okay, so it is clearly illustrated dito sa drawing natin, no? Is filled with gasoline. We have the specific gravity of 0.82 and accelerated horizontally at 3 meters per second squared. Okay, so it is filled with gasoline daw. Okay, and it is moved with a constant acceleration. In this case, that is 3 meters per second squared. Okay, babalik ko. When we say filled with gasoline, dapat pinuno siya or napuno siya ng gasoline, no? Kaya hanggang dito yung ating drawing dyan. So, ano yung mangyayari? Ipuno yung ating vessel, no? Close pa siya. Closed vessel siya. Okay? Take note, yung first situation natin is an open vessel. Pwedeng mag-spill, no? But here, it is a closed vessel. So, if this will move with that acceleration, it will be like this one. Yung orientation ng ating gasoline, no? So, hindi siya, walang lalabas na gasoline dyan. This is just an imaginary water level dito. Imaginary lang yan because if that will move, may imaginary reverse effective force tayo, no? That is opposite to the acceleration. So, it will tend to induce a imaginary pressure head. So, this is the imaginary pressure head natin. Yan yung scenario, basta closed vessel na at puno siya. Diretso siya pag ganyan. No, pag hindi siya puno, then, ang concept dyan is equate natin yung volume ng air to, di ba, yung volume of air in that case, pag closed vessel, constant lang kahit mag-move siya or hindi. Okay? So, in this case, puno siya, automatic, ganito yung itsura ng ating pressure head dito. This is just an imaginary water or oil dito. Okay? So, the same naman pa rin, we can calculate this angle of theta by using the formula. The same lang, no? So, by the way, for number 1, find the total force acting on the rear wall. So, ito yon. Ito yung rear wall natin, yung nasa likod. Then, the total force acting on the front wall. Okay, so unahin muna natin yung force acting on the rear wall. So, how can we solve this one? So, we can solve this one by the hydrostatic formula. Okay? So, imagine nyo, yung projected area natin dito is circle, no? Then ano yung formula? Gamma bar H area. So ito yung imaginary water surface natin dito at this position, no? So our bar H is from the water surface up to the centroid of the projected area. So that will be our bar H for calculating this one. That is just an hydrostatic force, no? So we should account this one. Of course, this bar H, as you can see, that will be Y plus half ng 1.5. Okay? So, we can solve this by this theta if we have that angle theta. Okay? So, that theta can be solved by this acceleration, 3 meters per second squared over the gravity. That is 17 degrees. Then, the Y here, considering this right triangle, that is just 4 tangent of 17. Okay, we have this dimension here, 4. Then we have the value of Y. Then we can just directly solve our force here on the rear wall. Gamma bar H area, so gamma of the oil, Sg times gamma of water, var H is 1.22 Y plus half ng 1.5 or 0.75 multiplied by this area. And that is 28 kilonewtons. Okay? Part 2 naman, the total force acting on the front wall. So, dito siya. Okay. So, how can we solve that? Okay, the same pa rin. Gamma bar H area. So, walang problema sa bar H natin dito since yung water surface natin, imaginary water surface is andito lang. So, gamma is 0.82 times 9.81. Bar H here should be half lang ng diameter or 0.75 times the projected area, the same projected area, and it will give us 10.66 kilonewtons. Okay, klaro? Actually, we can just solve that by using the reverse effective force, no? But hindi ko na lang ipapakita dito, baka malito pa kayo. Ganito na lang, hydrostatic force formula. Okay? Okay, part 3. Find the accelerating force on the liquid mass. Okay, ano yung accelerating force nga? Di ba that is equals to the reverse effective force or mass times acceleration. Okay, ito yung accelerating force natin. So, as you remember, that is just directly mass times acceleration. So, our mass here is Sg times the gravity, no? Ano? Mass is rho times volume. Now, this is the rho of the oil, no? Sg times the rho of water. This whole term is rho of the oil. This is the volume of the oil. Pi over 4 times diameter squared multiplied by 4. Then, i-multiply natin by acceleration. Then, we have the value of accelerating force. Okay. Now, actually, if you will subtract this one to this one, ibibigay niya ito. Okay? Kasi ito yung principle ng reverse effective force. Well, anyway, wag nyo nang lituhin yung sarili nyo if hindi nyo pa kaya. I know some of our students is first look pa lang ito, no? Yung reverse effective force. Hindi masyadong na-discuss ito sa undergrad natin. Okay? So, ganito lang yan. Okay, so situation 4. A vessel is 3.5 meters in diameter containing 2.44 meters of water is being raised. So, ito yon. Height ng water is 2.44. Then, its diameter is 3.05. It will be raised by a constant acceleration. So, for number 1, find the pressure at the bottom of the vessel when the velocity is constant. Okay, so ano yung formula? Di ba ito yon? Pag may acceleration, plus or minus. So when the velocity is constant, the acceleration is 0. Therefore, our solution here is gamma times h times the constant here, or factor natin. Take note that acceleration when the velocity is constant, that should be 0. And that is the answer. Okay, dali lang to. Part 2, find the pressure, the same pa rin at the bottom of the vessel when it is accelerating at 0.6 meters per second upward. Okay, so using that formula, okay, so gamma times h times 1 plus acceleration 0.6. Okay, so that will be positive since that is going up, no? Over the gravity. And this is the answer. Part 3, find the pressure at the bottom of the vessel when it is accelerating 0.6 pa rin. But that is downward motion. So, ano yung magbabago? Accelerating downward motion. So, magiging negative lang siya. Minus lang. Then, that is 22.47 kilopascal. For number 4, find the pressure at the bottom of the vessel when it is decelerating 0.4 meters per second upward. Okay. So, decelerating, ano yung ibig sabihin? So, take note that this statement here, that is moving upward, so that will be positive. Okay, plus. But, our that is a deceleration. That means, yung A natin dito is negative. So, over 9.81. And it will give us this answer. Yan yung mga iti-take note natin, itong mga words na to. Upward and deceleration. Okay, number 5, find the pressure at the bottom of the vessel when it is decelerating 0.4 meters per second. I mean, accelerating. Okay, accelerating 0.4 meters per second. But, downward yung motion natin. Okay, so how can we solve that? Downward yung motion, ito yung significance yan. Pag downward, meaning minus to. Then, accelerating, meaning positive to, yung A natin dito. Okay? It will give us this answer. The same lang. Okay, yan yung tatandaan nyo. Downward or upward, that will signify this plus or minus, no? Then, decelerating and accelerating, yung A yung titingnan natin. Negative or positive ba siya? Okay, so ganito yung mga variation ng problem na to. I hope you understand this one kasi binabalik ito sa board exam, no? Mga ganitong klaseng tanungan. Okay, so rotating vessels tayo. Situation 4, an open cylindrical tank 1 meters in diameter and 1.6 meters high contains water 1 meter deep. Okay, so ito yung statement dyan. We have the vessel, open vessel. And if the tank is rotated about its vertical axis, what speed should have so that the water just reach the rim of the tank in RPM? Okay, so unahin na ito, number 1. Yung water daw will just reach the tank. In this case. Okay, pag pinaikot natin yan, of course, it will create an imaginary paraboloid. So, ito yon. So, ano yung gagawin natin? So, using this formula, no, makukuha natin yung y natin. That one. Ano, ang focus natin dito is to calculate the omega, the angular speed. Now, how can we solve this one? Okay. Ito yung original position ng water natin. Yung hindi pa siya nag-rotate, no? So, ito yung tatandaan natin. Kung ano yung iaangat ng water dyan sa itaas, yan yung ibababa ng ating water din. That means, this is y over 2 and this is y over 2. Okay, klaro? Kung ano yung iaangat niya dyan, yan yung ibababa niya ng ating paraboloid. The same lang yan. That is y over 2. But, we can just use this one if yung ating water level is greater than half ng greater half full. Kumbaga, hindi siya less than half full. Okay? I hope hindi kayo malito. Basta, greater than the half of the capacity ng ating vessel. Di ba? If this is 1.6, then half nito is 0.8. So, that is greater than 0.8. So, magagamit natin ito. Pag that is lesser than the half of this height, then pwedeng mag-touch man ng ating yung vertex o vortex ng ating parabola dito. Kaya hindi natin ito magagamit. Okay? So, again, ganito mga problems lang naman yung lumalabas sa board exam natin. So, I hope you can master this one. Ano yung iaangat? Yan yung ibababa. That is because of the formula of the paraboloid. Okay. So, by knowing this one, this is 0.6. Okay? That is 1.6 minus 1. Therefore, we can solve our y here. That is y over 2 is equals to 0.6. Then, we can just say that y is equals to twice of 0.6. Now, this total y. So, we have the value of y as 1.2 meters. Now, we can solve our omega here using that formula. Okay, so, tingnan nyo. I will just cross-multiply this 2g here, kaya naging ganito. Then, cross-multiply yung r squared. The radius of this one, that is 0.5, no? 0.5. Then, square ko siya para matanggal ko yung squared dito. No? Square root pala. Okay, ito yung ginawa ko. Just a simple algebra. Then, we can have the value of omega, 9.7 radians per second. But take note, yung tinatanong is in revolutions per minute. So, we should convert this one. So, by these factors. Okay? 2 pi radian is equals to 1 revolution. Okay? That is for us to cancel out this radian. Then, 60 seconds is equals to 1 minute. Okay? So, yung matitirang unit natin is revolution per minute or RPM. Ito yung mga questions kalimitan. Dapat naka-RPM yung omega natin. Okay? So, tatandaan nyo na lang, diretso, no? Pag we want to convert radians per second to RPM, i-multiply lang natin siya by 30 over pi. Okay? 60 over 2 is 30. And divided by pi. Automatic na. Okay? Diretso na tayo. Para madali kayong mag-solve. Okay, number 2. The depth of water at the center is 0. Ano yung revolution natin or yung angular speed? When the water at the center daw is 0. So, ito yung sinasabi niya. It will just touch the bottom dito. So, in this case, klarong-klaro, yung y natin is the height of the cylinder. Okay, so our y here is 1.6. Then again, using this one, then I just rearrange again or simplify. Then we can have the value of omega. Again, diretso ko na lang siya, 30 over pi. Okay, para hindi na tayo dumaan dito. Then, ito yung answer. Okay, for number 3, there is no water at the bottom within 0.3 from the vertical axis. That is from the vertical axis. So, if you can imagine that one, pag magkakaroon na ng parang hole or wala ng water dito sa gitna, our imaginary paraboloid will be this one. Okay? So, hindi ito nabutas ha. Hindi nabutas yung ating vessel. Magkakaroon lang ng hole dyan. Hindi butas, magkakaroon lang ng parang void ng water dyan. O parang pag pinaikot mo yung palanggana with water, magkakaroon yan ng hole dyan. Okay? Now, it is stated here that the water here is 0.3 daw. No? There is no water 0.3 from the vertical axis. From this one up to that one. Okay? So, take note, we should calculate the value of y in order for us to calculate the omega. Okay, ito yung y na kukunin dapat natin. This is just an imaginary paraboloid dito sa baba. Okay? So, in order for us to calculate that one, let's call this one as y sub 1 dito sa baba. We have this 1.6 naman. Okay? Then we have 0.3 here. Now, we'll do SPP, square properties of parabola. Okay, look at this one. take note that this y sub 1 is equals to y minus 1.6. Okay? Y minus 1.6 is to 0.3 squared, yung x natin, x squared, is equals to total y is to, ano yung distance natin from here up to that point. That is just the radius of this cylinder over 0.5 squared. And here, we calculated the value of y. Then, we can solve the omega. Again, multiply natin by 30 over pi para RPM na siya diretso. Okay? I hope you understand this one. Okay, situation 5. An open cylindrical tank pa rin, 0.3 meters in diameter and 0.8 meters tall, as you can see in the figure, is filled with water. That one. Filled meaning napuno siya ng water. Revolve about its own vertical axis at a constant angular speed. Okay, so ano yung mga tinatanong dito? What angular speed will cause 1.4 liters of water to spill? Okay, spilling na naman. Spilling of water. Okay, so unahin muna natin yung number 1. Okay, if this is rotated about that axis, okay, of course, magkakaroon na yan ng spill. Initially, puno siya. So, how can we calculate this spill? Ito yung nayabo, no? Okay, part 1. Yung volume of this paraboloid, yan yung mawawala or yan yung nag-spill, di ba? Imagine nyo, this is a volume of air na lang, yung volume ng paraboloid. And volume of paraboloid is given by this formula, 1/2 pi r squared times the height of the paraboloid. Okay? So, take note that yung tinatanong is angular speed, then we should have this value of y. Okay? Take note that 1.4 liters, we can substitute this one dito sa volume. In that case, makukuha natin yung y. Okay? Cross-multiply lang natin on 2. So, that will be twice of the volume over pi r squared. And we have the value of y here. Now, after we have the value of y, we can calculate the omega or the angular rotation by this one. The same kanina. Okay? Just follow the values, then multiply by 30 over pi. Diretso na siya, RPM. Okay, number 2, what will be the depth of water in the tank when it is brought to rest from an angular speed of 240 RPM? Okay, pinaikot daw natin siya by 240 RPM. Then after that, it will become rest or it will be in rest position. Then after that, ano yung depth of water in that case? Okay, take note, but pag pinaikot natin to ng malakas, at 1, so we have the omega here, no? 240. So by using this formula, kukunin muna natin yung y, no? So omega squared, so omega converted to radians per second. In this formula, dapat radians per second. No, RPM converted to radians per second. So maging baliktad siya, times pi over 30. From this one, then baliktad naman siya, gawin natin siyang radians per second. So reciprocal nito. So diretso ko na lang. Okay? We have the value of 0.7244. Okay? So after this one, how can we calculate the depth of water when it comes to rest? Okay. So ito yung magiging case scenario natin. Magiging 0.7244 yung ating y, no? Pag pinaikot natin siya ng 240 RPM. Almost 0.8 na siya. Now again, take note, pag hindi lang umabot itong vortex natin dito sa bottom, then we can just use yung sinabi ko, yung ano yung iaangat ng ating parabola sa taas, dito. The same yan ang ibababa niya. And, oh, nawala. Okay. Okay, let me just go back. Okay. Nawala ako. Ito yun, no? Kung ano yung iaangat niya sa taas, yan yung ibababa niya. That means, this one is y over 2. Okay, y over 2, then this is also y over 2. Okay, so if we have the value of y here, then yung tinatanong is yung water level after siya umikot or become rest na siya, ito yung h natin. Ito yung tinatanong dyan. So, as you can see, that will be 0.8 minus y over 2. Okay, so we can just directly solve that. 0.8 minus y over 2 or 1/2 of that y. That is 0.438 meters. And that is the answer. Okay. Okay, part 3. Angular speed, that the depth of water at the center is 0 lang. I know, the pressure at the center bottom is 0. So, magiging 0 yung ating pressure dito kung walang water dito. So, the vortex should be touching lang the vortex dyan. Okay? So, as you can see, yung y natin dito is 0.8 automatic. Okay? So, by that, diretso ko na lang, no? The same formula kanina, yung i-arrange natin. Then, we can have the value of omega. Okay? So, this is for open vessels. For the next video, that will be a closed vessels.